Welcome back. Now that we are familiar with our Ohio Level 1 manual, let's proceed with the presentation portion of our training. Welcome to Ohio Level 1 Aggregate Technician Training. This is being presented in cooperation with the Ohio Department of Transportation, the Federal Highway Administration, and the Ohio Aggregates and Industrial Minerals Association. Aggregate segregation is the separation of coarse and fine aggregate. We will learn the causes of segregation, the problems created, and ways that we can stockpile to minimize aggregate segregation. We will learn of the importance of proper loadout and sampling techniques, how to minimize segregation in loads or samples, and explore potential problems and solutions. There are many possible consequences, most of them negative, associated with segregation of aggregates. The techniques learned here will minimize segregation and the associate risks. It is important to remember that we are using a relatively small sample, in this case 70 pounds of material, to make a determination of the contents of a very large stockpile, in this case nearly 50,000 tons. So we must use consistent and approved techniques to ensure the reliability of our test results. What's wrong with this picture? In this case, the technicians are sampling a very large stockpile using only manual methods, including a shovel and bags. The loader in the background should be a part of the process. What size aggregate are the samplers likely to obtain? If you said coarse aggregate from the toe of the stockpile, you would be correct. Knowledge of the placement of the material into the stockpile is critical to recovering representative samples. In this photo, the conveyor is moving from left to right. You should note that the coarse material is concentrated towards the front of the stockpile, and the fines are toward the rear of the stockpile. This illustrates an extreme segregation case, but we need to be mindful that all aggregates exhibit similar characteristics. Here are the stockpile construction and segregation factors: aggregate size, belt speed, the height of drop, and gravity. This can be found on page 11 of your manual. In addition, wind and weather, moisture content of the product, stockyard space restrictions, special products and materials can have various different segregation characteristics. Note that due to high winds, the normal segregation characteristics are reversed as the wind blows the fines to the front of the pile. What could be done to minimize the effect of the wind? If you said lowering the conveyor belt, you are correct. It is important to take note of extreme conditions when approaching a stockpile or taking samples. Unexpected test results may be attributed to these extreme conditions. Think to yourself, why is stockpile management important and why does it matter? Ask yourself these questions. What happens to the aggregate prior to being placed in the stockpile? What effect does the method of stockpiling have on the end product or sample? How does loadout technique affect the product and/or sample? What can we do to minimize these effects? Ask yourself how a poor or unrepresentative sample could affect these factors: the design, the cost, the project, the customer. Can you think of other outcomes? This is an example from an Ohio aggregate workshop in 1996. Sample A was taken from the front. See the gradation to the right. Sample B was taken from the middle. Sample C was taken to the rear of the pile. As noted earlier, gravity allows fine material to move to the bottom of the belt while coarse moves to the top. Vibration and length of belt travel can compound this movement. If we were to recombine samples A, B, and C, our gradation matches the expected gradation of the material acquired from belt cuts. This is a great illustration of why we sample from the front, middle, and back of the stockpiles and combine the samples. This screenshot, taken from the video you are about to see, demonstrates the movement of fines to the bottom and coarse aggregate to the top of a moving conveyor. This segregation of coarse and fine materials is shown in the screenshot. So when we combine the three samples from the example, we get a gradation that is very close to the known content of the stockpile. This is the basis of the front, middle, back sampling procedure that we will discuss. What if an erroneous gradation due to poor sampling practices were used in the design of an asphalt or concrete mix? We want our mixes to be a consistent combination of coarse and fine particles that interlock and give stability. If we are not consistent in our testing and sampling, we jeopardize the integrity of the asphalt or concrete mixes. Aggregate gradation specifics are found in Section 703 of the ODOT CMS. Here are the standard sizes of processed aggregate. Ask yourself what would happen to an asphalt mix given this scenario. Designed using inaccurate information, for example, fine aggregate from a conveyor side or stockpile used to design the mix. The mix meets design criteria using the finer material. Fine material was used to design the mix, but coarse material is delivered to the asphalt plant. What are the possible consequences? Notice the rutting of the asphalt pavement. This is severe rutting. Here is flushing and bleeding and raveling. Other pavement distresses can occur due to poor stockpile management, poor sampling, or poor quality control procedures, including longitudinal, transverse, and block cracking. These are just a few of the negative consequences a producer may experience due to poor stockpiling, sampling, or testing. Can you think of others? Our customers see project delays and downtime resulting on poor perception and loss of credibility. We have to have a plan to deal with failed tests or questionable results. What does our quality control plan say? Remember, the segregation characteristics exhibited by aggregates can apply to all transportation uses, such as in the truck bed, in the paver, in the mixer, and in the subbase. Remember, our job as aggregate producers, suppliers, and technicians and/or loader operators is very important. Errors in loadout and production sampling can have far-reaching consequences. We must be fully aware of the possible consequences in order to avoid them. We must be willing to take time to assess all possible sources of error. Accuracy is more important than speed of results, and use of improper recovery techniques always leads to trouble. We must use accepted recovery and sampling practices to ensure reproducibility, precision, and reduction of errors. The loader operator is one of the most important links in the quality control chain. The knowledge and utilization of the simple tools and techniques presented in this course will ensure that a quality product reaches the end user, because quality is everyone's responsibility, and communication is the key to a successful quality control program. The bottom line is increased accountability. Can you defend your results? By using the knowledge acquired through Level 1 aggregate technician training, we're able to ensure consistent and reliable results. We'll be right back.